Okay, this is lesson 6.2 for Algebra 2. It's on comparing functions. Oh, we have math humor. Quadratic. Exponential. You've got it made. You're always so positive. Exponential. Yes, but what about you? Well, I have my ups and downs. Yeah, so do the polynomials. So we'll start off with comparing the average rates of change of two functions. Katie and Jackie swim laps every day. They keep track of the time it takes to complete their laps. Jackie's times are shown in a graph, and Katie's times are shown in a table. Compare the average rates and explain what the difference in rate of changes represents. And then I also have on here to write equations of lines. That's just so we can get some more practice with those. What I'm going to do too is actually let's shrink these down a little so I have some room. Ooh, it's going to shrink the whole thing. Oh well. That's okay though, we can still see it. That's pretty good there. And then I'll move that out of the way. That's pretty good. So first of all, let's find Jackie's. So her rate of change is the same thing as her slope. So to find slope, we need 2 points. And a good idea is to use ones that are far apart. So I'm going to use the point 2, 1.2, and the other point is 20 and 12.4. So we've talked recently about slope being the change in the y's over the change in the x's, so make sure you do your y's on top, 12.4 minus 1.2. Since I started on the second point, I need to start on the second point on the bottom as well. So 12.4 minus 1.2 is 11.2 divided by 18. And I've probably got that worked out ahead of time to save time here. So yes, that ends up being 0.62. And we need to put units on there. So it's going to be, slope is rise over run, so change in y over change in x. The units on the y will go on top, so that's minutes. And the units of the x are laps. So about average of 0.62 minutes per lap. And then let's go ahead and do Katie's over here. So again, I'm going to use the two that are furthest apart and do rise over run. 11.77 minus 1.08. I'm kind of taking a little bit of a shortcut by not writing out the points ahead of time. So I'm doing the y's, changing y's on top. Since I started with this point, I have to start with this point on the bottom. Again, it's 20 minus 2. So when you end up subtracting those, you get 10.69 divided by 18 again, and then that's 0.59, and it's still the y. Oh, yeah, ignore that. That's just doing some video converting there. 0.59, where was I? Lost track. Oh, I was doing the units. It's going to be minutes per lap again, which is good because we want to compare them. Whoops, minutes per lap, so we want the same units. Okay, so who is fastest? Well, the person that can do the lap in the shortest amount of time is going to be faster, right? So that's going to be Katie. It takes her less time to do a lap. Now the book has a typo because they said that if you look in there, it says that Jackie is faster, but that doesn't make the least bit of sense. So Katie is faster. She has a I think maybe they must have been thinking laps per minute, perhaps. Maybe that's why they made that mistake. But if it's minutes per lap, if it takes you less time, then you're going to be going faster per lap. Less time per lap. All right. Now we need to write equations of lines just because we really want to make sure we practice those. So I'll work with Katie since I'm working with hers. Remember the point slope formula. I'll just write it down. And we already found the rate of change. That's the slope. So I know the m is 0.59. I know the y is part of the equation. And I'm going to choose, it doesn't really matter which point you choose. So I'm just going to choose the first one right here. Remember, this is the x1, this is the y1. So I'm going to be putting in 1.08 for my y1. And my x1 is 2. And that's the equation of the line for her. If you want, you can distribute and simplify, but you don't have to. And then this one, again, same thing, y minus y1 equals m times x minus x1. And y minus, I think I'll go ahead and choose this first point as well. So 1.2 is my y, 0.62 is my m. X is part of the equation. X1, the one that goes with the 1.2 is 2. And there's the equation for Jackie. So there's the equations of the lines. Sometimes too, it is a good idea to distribute and simplify because then you can you'll know the y-intercept. So maybe I'll do that with one of these. I'll do it with this one because I have more room over here. So I'm going to distribute 0.59 times x. Let's see, 0.6 times 2 would be 1.2, so it's going to be 1.18 negative. And then you can add the plus the 1.08. And that's going to be negative 0.10. Oh, it's kind of hard to tell if that's right. If you went down 2 more, down 1, yeah, it's probably reasonable. These look like they're going down roughly by a little over 1, so you would get a negative value there. All right, let's move on. It is really important. I really do want you to know how to use the point-slope formula and write equations of lines. That's a really important skill for an Algebra 2 student to have. So this is an on your own. I'm not going to take the time to work through it. It's the same exact type of question. What I will do though for you is I will give you the answers, which means I have to find them. So it looks like Mike, his slope, or his rated, I'll call it M, was $26 per week, and John's was $25.57 per week. Make sure you put units on your answers. And I did say write the equations of the lines. Looking through my notes to see if I actually have those. I maybe don't. No. Sorry, I don't have that handy. So we'll just have to skip that part, I guess. Example 2. Saul launched an object from the ground. The graph for the height of the object, h of t, in meters after t seconds passes through those points. And notice we have some decimals. Sketch a graph of the quadratic equation that models the situation. And we would know it's quadratic because it's height versus time when you're shooting an object in the air is quadratic. And find the point that represents the maximum height of the object. Well, I look at this and I think calculator because I've got decimals and I can sketch it on a calculator pretty easily. I can find the maximum height on a calculator. Looking at the book, they did it by hand, but I am not going to drag you through that. It's hard enough doing these with integers, let alone decimals. So let's take the easy route on this one and put them in our calculator. So this is actually a review. I mean, we did this in 6.1, didn't we? So I'll kind of go through this somewhat quickly because you've already done this. So we'll put our data in stat, enter. The x's will go in L1, so that's 0, 2, and 1.5. And then in our y's, we'll have 0 again, 3.2, and 6.075. Oops, see, I have trouble with this thing today. 0. Okay. Window. The x's are going from 0 to 1, actually up to 2. So I'm going to keep my x's from, let's go negative 1 to 3. How about? Maybe I'll do 4. My y's are going from 0 to 6. So let's do negative 1 to 10. That sounds good. And I have to turn on my stat plots. Enter, graph. Yeah, there's only 3 points. You can see all 3 of them. We know that we want it to be quadratic, so we're going to go to stat, back to a blank screen, stat, calc, and it's quadreg 5. And I am going to be finding the maximum height, so I do need the equation. I want to put it in y equals so that it will graph it. So I need to do vars, y vars, and so on. Pick y1. Okay, there's my equation. Notice c happens to be 0, which we knew because it intercepts there. Y-intercept is 0. Let's take a look at the graph. Looks great. And we can clearly see that the maximum is on there, so we're now able to find the maximum, which is second trace, option 4. We need to move to the left of it, enter, to the right of it, enter, and then the guess. And then it does say find the point that represents the maximum height, so we'll give both coordinates since it says point, 1.16 and 6.63. So at 1.16 seconds, this is in seconds, it will be, is that in meters or is that feet? What does it say? Does it say meters? 6.63 meters high. Okay. Sounds good. Let's move on. Okay. This is one for you to try on your own. It again tells you that it's quadratic. So do the same exact thing, and I will give you the answer, how about? So I won't take up your time here on the video. Let's see if I don't have it somewhere here. Oh, good. On your own, number 2. Okay, this is what I have here in my notes. Oh, so this must be in feet. Yep, feet. 16 is a clue to that. And the maximum height is 61.25 feet. Okay, example 3. So this is a new idea. Well, it's not really, it's sort of new. We've done end behavior in this class before, haven't we? Comparing the end behaviors of two functions. So last time, back in chapter 2 or maybe it was chapter 3, we looked at end behavior. And we just looked at it for one function. We did not look at it, we did not compare two functions. So maybe, hopefully you know what these two functions look like. If you don't, then you should graph them on a calculator. F of x equals 3 to the x. Hopefully you recognize that that's an exponential. And it's going to be going through the point 0, 1. And when x is 1, y is 3. So it goes through those points, and it has a shape like that. So that's f of x. If you didn't remember, don't feel too bad. Go ahead and graph it on your calculator, and you'll see that if you typed it in correctly, you should get that. Then g of x is x to the 4th. That one you may not be familiar with. It looks a lot like a parabola, but it's actually a lot flatter down here at the bottom because the parabola is going to, well, they both go through these points, these 3 points. Because if you plug in 1 and raise it to the 4th, you're going to get 1. So just like a parabola, it goes through those, but instead of kind of curving up, it's flat down here. It reminds me of a fencing staple. They look kind of like that. So that's g of x. Feel free to use calculator on those. So now we get to describe the end behavior. So we could say that, remember when we describe end behavior, we're looking for when the x's get really large in the positive direction, so as x approaches infinity, in other words, and as x gets really large in the negative direction, or as x approaches negative infinity. So we'll write it up the way the book does. As x approaches positive infinity, what's f of x approaching? Well, for that, you're looking at the y values. So think about you're sliding along here as you're getting the x's, you're going this way, so you're moving along this part of the curve. It's going to go up, 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 up. So f of x is going to approach positive infinity. And since we're comparing, we can also say, and g of x, well, it's also approaching positive infinity. So that's on the right-hand side. We also have to discuss and consider the left-hand side. So as x, whoopsie, that's supposed to be an x. Here, x approaches negative infinity, what is f of x doing? Well, this one's a little interesting. We haven't really talked about this one so much. say you're a little point on the curve and you're moving along in the negative direction. What y values is this approaching? Is it going down forever to negative infinity? No, this is an asymptote, isn't it? That means it's never going to drop below that line. It's going to just keep going along, along, along. What y value is it approaching? It's approaching y equals 0. Is it ever going to reach 0? And the answer is no. It's just going to get closer and closer. And don't forget, we also have to discuss g of x. And g of x will be approaching, okay, g of x is the pink one. So as I'm going to the left, I'm a point on the curve. I'm moving, left, 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 and the y's are going up, 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 up to infinity. So that's how we're going to write our answers when we're comparing these n behaviors. Okay, try this one on your own. I'll do the answers real quickly. I won't take as much time to explain. 4x squared looks like that. And g of x, x cubed looks like this, sort of roughly. I'm just really concerned just about the shape, not so much exactly where it's at. So the answer would be, as x approaches infinity, both f of x and g of x approach infinity. And as x approaches negative infinity, f of x will approach positive infinity and g of x will approach negative infinity. It does go down forever, downward. And this is a table apparently out of the book, so let's see what we got here. On this one, so this is an exponential. So this is going to be true for all exponentials where the a is greater than 0. As x approaches infinity, what does y approach? If you said infinity, you would be right. As x approaches negative infinity, we already saw that. That's going to be equal to approaching 0. And then if a is negative, remember a negative out front, that's going to be a reflection over the x-axis. So we have this beautiful graph here. As x approaches positive infinity, the y's are going to approach negative infinity. Whoops, so this should be a negative infinity. And then as x approaches negative infinity, again, the y's are going to approach 0. I don't think you necessarily need to write this down. So if it makes sense to you, then I think we're good to go. Oh boy. You know what I did last year? These notes came from last year's. I decided that we had better, because this is as far as the book went. Although, they did do it by hand when they had the 3 points with the quadratic, but they had those ugly decimals. What I decided we should do is practice these. You've been in the class several months since you first did these. I bet you can do these a little more easily. So let me take some time to go through this whole process again of how to find the quadratic by hand. Okay, I'll try to go somewhat slowly, but not too slow. Y equals ax squared plus bx plus c. That's a quadratic, so you start there. And then remember, you plug all the points in. So this is x and y and so on. So I'm going to label them because it's easier, I think, if I label them. We're going to have 3 equations. A we don't know. I'll go ahead and do negative. Well, here, we'll do it the slow way. B, x is negative 2 plus c. And then 8 will go in for y. Whoops, that's a positive 1. Oh, sorry. It's hard because I have to look up and my neck gets sore. X is 1. And then the last one, 22. 3 squared plus b times 3 plus c. So that's the original setup. Then I'm going to go through and simplify these slightly. So that's going to be 4a minus 2b plus c. 8 equals a plus b plus c. And then 22 equals 9a plus 3b plus c. Okay. So, what we want to do here, sorry. I was looking to see if we had any easy ones. Remember the really easy ones were the ones where you had like a 0 and then some number, 10 or whatever. We don't have that in this case. So we don't have the super, super easy ones. But what we can do is it's easiest to eliminate C is what I meant to say. It's easiest to eliminate C. So let's take these first 2 and let's eliminate C. And the way we're going to do that at least the way I would like to do it, is to negate or change the sign on every one of these terms and then add those two equations. So I'm going to have, I'll take my work down here because I don't want to pollute this. I'm going to negate all of these, change their sign, so they'll all become negative in this case. Then I'm going to add them. So 17 minus 8, and then that's 3a, that's negative 3b, and those cancel. Then I'm going to go back and do the same thing with these other two. So this time, I like to have these down on bottom for whatever reason. So I'm going to put my 22 equals 9a plus 3b plus c on top. Then I'm going to negate this middle one again and put it down below, just because I like to put those down there. They're easier to subtract that way. And then we're going to add them. 22 minus 8 is 14. 8a. And go slow here so you don't want to make stupid mistakes, right? Because one little mistake, and man, it just throws the whole problem off. And then the c's cancel. Now, we are ready to now work with these two equations. So I'm going to go to a different color. Actually, I really like this color. Not that color. Okay, so let's bring these together. 14 equals 8a plus 2b, and 9 equals 3a minus 3b. And I think it's going to be easiest to get rid of the b's, because one's already positive and one's negative. So we're going to multiply the top one by 3, because we need to get a least common denominator, or least common multiple, which would be 6. That means I have to make this top one I have to multiply by 3. The bottom one I need to multiply by 2. So that's going to give me 3 times 14. I should know that. Let's see, that's 42. And then 18 equals 6a minus 6b. And we're going to add these. Let's see, that's 60. And that's 30, which is very nice. I get a nice result here. Divide both sides by 30. A is 2. And once you find a, it's not bad. All you got to do is put that back into either one of these equations. I think I prefer this one down here. So I'm going to do 9 equals 3 times 2 minus 3b. 9 equals 6 minus 3b. I prefer to add my 3b over and subtract my 9. Of course, I'm still going to get a negative either way. And I get b equals negative 1. You could check that too. Negative 1 times negative 3 is positive 3. 3 plus 6 is 9. I like to do little checks just to make sure I'm not making the stupid mistake. And now all we have to do, we're almost there. We have our a and our b. We can just, I'm going to pick this easy one here and plug those back in there. So I've got 8 equals a, which is 2, plus b, which is negative 1, plus c, which is what I'm trying to find. So 8 equals 1 plus c. That means c must be 7. And then we'll write the equation up here because that's where I have room to do it. ax squared, so 2x squared plus bx, which is negative 1x, plus c, which is 7. And then to check it, a fast way to check it is to just put this in in y1. Look in your table and see if these values are in your table. I'm definitely wanting to check this because remember how easy it was to make mistakes. 2x squared minus x plus 7. And to check it, I'm going to make my table. Let's start it at negative 2, how about? And we'll count by ones. Okay, negative 217 is on there. 18 is on there. 322 is on there. So we know we did it correctly. On this next slide, try this on your own, again by hand, because we want to get good at this. And I'm just going to give the answers to save time, and if you want, we can always do this in class. So let us see here. Okay, I am finding it, and I am finding the answer to B. So here's your answer. Voila. And we have one more slide, it looks like. Oh, smiley face. How about that? Right on. Okay, see you in class.